Hello. Hello and welcome to this video. In this video, we will look at Enum support functions as well as geometric functions and operators. So if you remember or if you have watched the playlist, then you would know that in one of the videos, I have shown quite a few examples of geometric shapes and data. So I will not show examples for geometric shape and data. One of the reasons is that they are already done. The second reason is that for anything serious, you would be actually using the PostgIS extension rather than using the native shapes and other things. So for geometric shapes, we won't consider examples, but for Enum support, we will have an example which is already given here. So let's get started. And I apologize for the delay in the video. The last video was 3 days ago. Things happen in life. Okay. So enum was described in section 8.7. There are several functions that allow cleaner programming without hard coding particular values of an enum type. So these functions are listed in table 9.35. So these functions require you to have enum of this type. So what we are going to do is on Postgres, we create this enum. Okay. And then we select enum first. So enum first, if you supply any enum, it will give you the first value of that enum. Okay. And we have read as the first element. Similarly, for the last element, we will have purple. So you can select that as well. And we have purple. So that's how you're supposed to execute the queries for the exercise, for the examples of this one. Then we have enum range, which returns all values of the input enum type in the ordered array. So you can say this, and it will give you all the enum values. Then we have enum range. It takes two arguments. Returns the range between the two given enum values as an ordered array. The values must be from the same enum type. If the first parameter is null, the result will start with the first value of the enum type. If the second parameter is null, the result will end with the last value of the enum type. So for example, between orange and green, so as you can see, between orange and green, we have yellow. Oops. So between oh, it was not copied. Select. So we got orange, yellow, and green. Okay. So you see the terminal is intelligent enough to show us colors. Okay. Now if the first element is null, it will start from the first one and go till the second element. And if the second element is null, then it will go to the first element. Okay. So that's how we get that. Okay. And to get all the elements, we use enum range function with a null argument, which has to be classified by the enum name. Notice that except for the two argument form of enum range, these functions disregard the specific value passed to them. They care only about its declared data type, either null or a specific value of the type can be passed with the same result. It is more common to apply these functions to a table column or function argument than to a hardware type name as viewed in the examples. Then we have geometric functions and operators, and I'll repeat that for anything serious, you need the PostgIS extension. And examples we have already covered. So we'll quickly rush through the examples of, or rather, functions and operators of this. So let's go through it. The geometric types point, box, line, segment, line, path, polygon, and circle have a large set of native support functions and operators shown in tables 36, 37, and 38. First is geometric operators. So you add a geometric type with a point to get a geometric type. adds the coordinates of the second point to those of each point in the first argument, thus performing translation. So for example, if you have a box with the argument with the points 1, 1 and 0, 0, and you add 0.20, then both the points will be translated. That is, the points will be added to that. So for example, you can try to run this, not up to there, up to here. Okay, you copy this and you execute, select, and there we go. Then we have path plus path. It will give us a path. It concatenates two open paths. Return null if other path is closed. So 0011 is added to 223344. Then we have geometric type minus point will again translate just like addition, reverse of addition. Then we multiply with the point, multiplies each point of the first argument by the second argument, treating the point as being a complex number represented by real and imaginary parts and performing standard complex multiplication. If one interprets the second point as a vector, this is equivalent to scaling the object size and distance from the origin by the length of the vector, and rotating it counterclockwise around the origin by vector angle from the x-axis. It is available for point, box, path, and circle. There is a footnote A which you will read. Oh, where's the footnote? There should be a footnote, right? A footnote should be there. Yep, here. Rotating a box with these operators only moves its corner points. The box is still considered to have sides parallel to the axis, hence the box's size is not preserved as a true rotation would do. So that is the footnote about box. So if you have path 0, 0, 1, 0, 1, 1 and yeah, here, and you multiply with 3, then it will do the vector multiplication and all that. Okay. Then we have division, divides each point of the first argument by the second point, just like multiplication. It will be like complex division. If one interprets the second point as a vector, this is equivalent to scaling the object size and distance from the origin down by the length of the vector and rotating it clockwise around the origin by the vector's angle from the x-axis. Available for point, box, path, circle. Same footnote is here also. Then we have at the rate minus at the rate geometric type, which gives the length of geometric type. It is available for line segment and path. So for example, if you compute the path of line segment 0, 0, 1, 0, 1, 1, it is a path. So it will give you 2. Okay. So let me show you. Select and paste it, and I get 2 as the output. Then we have at the rate geometric type, which computes the center point available for box, line segment, polygon, and circle. So you can run this just like previous one and get the output. Hash geometric type integer returns the number of points available for path and polygon. Geometric type hash geometric type computes the point of intersection or null if there is none available for line segment and line. Box hash box computes the intersection of two boxes or null if there is none. Geometric type hash geometric type computes the closest point to the first object on the second object. Available for these pair of types: point box, point line segment, point line, line segment box, line segment, line and line segment. Geometric type left angle bracket minus right angle bracket geometric type computes the distance between the objects. Available for all 7 geometric types for all combination of point with another geometric type, and for these additional pairs of types: box, line segment, line, polygon, and circle. Then we have geometric type at the rate geometric type. Does the first object contain second? Available for these pair of types: box comma point, box comma box, path comma point, polygon comma point, polygon comma polygon, circle comma point, circle comma circle. So for example, if you want to test if a circle centered at origin with radius 2 contains 0.11, then you do that, select, and it is true. Then it returns a boolean, by the way, okay, and this returns a point, this returns a double precision. Then we have geometric type, left angular bracket or less than at the rate geometric type. Is the first box contained in or on second? Available for these pair of types: point box, point line segment, point line, point path, point polygon, point circle, box, and so on. Then we have and operator, which takes two geometric type as arguments, and it checks whether the objects overlap or not. Available for box, polygon, and circle. Then we have geometric type less than geometric type, returns a boolean. Is the first object strictly left of second? Available for point, box, polygon, circle. Then we have greater than, so it is the first box strictly right of the second, so that's that. Then we have ampersand less than. Does first box not extend to the right of second? So it is available for box, polygon, circle. We have ampersand greater than for two geometric types. Does first object not extend to the left of second? Again available for box, polygon, circle. Less than or operator. Is first box strictly below second? Again available for point, box, polygon, circle. Then pipe or operator greater than. Is first object strictly above second? Available for point, box, polygon, circle. Then we have ampersand less than pipe. Does first box not extend above second? Available for box, polygon, circle. Similarly, here we have or ampersand greater than. Does first box not extend below second? Similarly, available for box, polygon, and circle. We can run these queries to get familiar with that. Then we have less than caret is first box below second, allows edges to touch. Then we have greater than caret between box, these are between box is first object above second, allows edges to touch. Then we have geometric type question mark hash. Do these objects intersect? Available for these pair of types: box, line segment, box, line segment, line segment, line segment, line box, line, path. So returns a boolean. Then we have question mark minus line and question mark minus line segment, both return boolean. It checks whether line is horizontal or not. Then we have point, question mark minus point. Are the points horizontally aligned? That is, we have the same y coordinate. Question mark pipeline, question mark pipeline segment, is line vertical. Then similarly, we have the same operator for point, which checks are the points vertically aligned. Then we have question mark minus pipe between two line segments and line and line segments. It checks are the lines perpendicular. And then we have similarly question mark double pipe, and as expected, it checks whether lines are parallel or not. Then we have the congruency test. Tilde is equal to, which checks if the objects are same. It is available for point, box, polygon, and circle. Then we have caution. Note that the same as operator represents the usual notion of equality for the point, box, polygon, and circle types. Some of the geometric types also have an is equal to operator, but is equal to compares for equal areas only. The other scalar comparison operators less than is equal to and so on were available for these types. Likewise, compare areas. Before PostgreSQL, we are not interested in ancient PostgreSQL. Let me see how many functions we have, so we can cover the functions. Okay. First, we have area, which takes a geometric type and returns the area. It is available for box, path, and circle. A path input must be closed as null is returned. Also, if the path is self-intersecting, the result may be meaningless. Then we have center, takes geometric type and computes center points for box and circle. We have diagonal, takes a box and extracts diagonal as a line segment, same as line segment box. Then we have now, so this box is basically represented by the bottom left and top right coordinates. So the diagonal will be the same. Then we have diameter of the circle, which computes diameter of circle. We have height of a box, which computes vertical size of box. Is closed, tests whether a path is closed or not, returns a boolean. We have is open for a path, which tests whether path is open or not, again a boolean. Then we have length of geometric type, which computes the total length. It is available for line, segment, and path. And points geometric type returns the number of points available for path and polygon. Then we have p-closed path converts path to closed form. So, for example, let me show you. So here, let me show you. So by closed form, it means that from 2, 0, there will be another line to 0, 0. You see, these three are in bracket, and this is in parentheses. So that's how it converts that, okay? Then it converts path to open form, p open. So here you have open form, that is parenthesis, and you get the open form in brackets. Then we have radius of a circle, which finds radius of a circle. Slope computes the slope of a line through 2 points. Then we have width, which takes a box, computes horizontal size of a box. So between 1, 2 and 1, 0, 0, the horizontal size is 1. Then we have type convergence, and that will be a big one. Now we can finish this. Okay. So let's go through geometric type conversion. Box takes an argument circle and gives a box, computes box inscribed within the circle. So this is the output, okay? How it computes, so if you look at the output, what we have is a circle of radius 2 centimeter, and the box is computed by taking the square root 2 coordinate, which is at 45-degree angle from x-axis, and minus root 2, which is in the third quadrant at angle 225 degrees from the positive direction of x-axis. Then we have box takes argument as points as argument and converts point to empty box. So if you give 1, 0, it will give you a box of 1, 0, 1, 0. We have box which takes 2 points, which converts any 2 corner points to box. We have box polygon, which gives the bounding box of polygon. Bound underscore box takes 2 box argument, computes bounding box of 2 boxes. We have circle, which takes a box, computes smallest circle enclosing box. Then we have circle point comma double precision, which constructs circle from the center and radius. We have circle, which takes a polygon, which converts polygon to a circle. The circle center is the mean of positions of the polygon points, and the radius is the average distance of the polygon's point from that center. Then we have line, takes 2 argument, converts 2 points to a line through them. We have line segment, a box which extracts boxes diagonal as a line segment. Your line segment takes 2 points, which construct a line segment from 2 endpoints. We have path, which takes a polygon, returns a path, converts polygon to a closed path with the same list of points. We have point, which takes 2 double precision numbers and construct points from its coordinates. Then we have point, which takes a box, which computes center of box. Point of a circle, which computes center of a circle. Point line segment computes center of the line segment. Point polygon computes center of the polygons, the mean of the positions of polygons points. Polygon takes a box, converts box to a 4-point polygon. Polygon takes a circle, which constructs a circle to a 12-point polygon. Then we have polygon takes integer and a circle, converts circle to an n-point polygon. Then we have polygon takes a path, gives a polygon, converts closed path to a polygon with the same list of points. It is possible to access the 2 component numbers of a point as though the point were an array with indexes 0 and 1. For example, if t.p is a point column, then select p0 from t, retrieves the x coordinate, and update t set p1 is equal to something, changes the y coordinate. In the same way, a value of type box or line segment can be treated as an array of 2-point values. And with this, we finish the geometric data type functions and operators, and next we have network address functions and operators, which we will start in the next video. And we still have a lot of content to go through. Okay, we are looking at 140 odd pages even now, so it should take something around a month to finish it. Okay. In a month, we will be through this chapter. That is, if I make the videos regularly. Okay, things happen, and then I'm not able to prepare the video. So for this particular video, I don't think an example is necessary. If and one has been already shown for numeric functions and operators, and Enum had basically 3-4 functions, right? So next we will look at network functions, and we will also begin text search functions and operators. And we will spend some time in text search function and operators, okay? Because this is what constitutes the full text search chapter. If you don't understand this, you won't be able to understand full text search of PostgreSQL, which is basically quite important. Okay. So I'll end this video here, and I hope that you are enjoying the playlist. If you have not watched previous videos, you should definitely go ahead and watch earlier videos. There are quite a few things you can learn from the previous videos. So with this, I will end this video, and I hope that you are learning and enjoying the playlist. So thanks a lot for watching the video, and I'll see you in the next one tomorrow. Till then, I will take my leave. So have a great day, and sayonara.